Hey Sam, I have your quiz here. The first question you missed says that the table below shows the number of color pages a printer prints out over a period of time. What is the constant of variation? So anytime you're going to calculate the constant of variation, you're always going to do y over x. And in these horizontal tables, you'll notice x is the top row and y is the bottom row. So you can take any ordered pair. I believe this is all about proportional relationships. So every ordered pair will always reduce down to the same fraction. So I can do 3 over 2, and you can see that is the correct answer. So it's always y over x. It looks like you selected x over y. Which function has the greatest constant of variation? So it says b, but I can't get this all to fit on my screen, so let's just calculate them all. So on all of these, you're just taking, again, y over x. And I always just do usually the first order pair because it's the smallest, so I have the smallest numbers to have to deal with. So you can do 20 divided by 8, you can use a calculator. You can just reduce the fraction and compare fractions. I typically like to just put things in a decimal when I'm comparing, because then I don't have to worry about common denominators or anything like that. In the next table, this is pretty easy, 3.2 over 1, that's just 3.2. So you can see right now this is table B and it is winning the race. I'm going to scroll down, we're going to remember 3.2 so I can look at these. So on both of these it can be like a counting game, right? The rise over the run. So if I start here and I go to here, so I'm going up 1 and over 3. So this one is 1/3 or 0.3 repeating. And here we're going up 4 and over 2. And so that's 2. We just count how far up you go over and then how far up you go and then how far over you go. So 4 over 2. So it looks like, again, that letter B, which was 3.2, was higher than all of them. Question 3. A botanist uses the representations below to show the height in inches of different plants over a period of time. If the growth pattern continues, how much taller is the tallest plant than the shortest plant at 120 weeks of growth? Well, here's 120 weeks of growth for this plant. It's 180 inches. Here's 120 inches of growth for that plant. It's 360. Wait, is it 100? Yeah, 120. It's 360. So 180, this one is 360. Now we have to figure out plant B. And so we actually have to plug in 120 for T. So 4 times 120 is 480, and if we divide that by 3, we get 160. So this is the tallest, and this is the shortest, and it asked how much taller it is. So we're going to take 360 minus 160, and we get 200. So it is 200 inches taller. And there's that answer there. So this is just, proportional relationships can be shown on a graph, they can be shown in a table, they can be shown in an equation. So that's what a problem like this is trying to get you to understand, is how to pick pieces out from each of those. The length of a spring varies directly with the mass of the object that it's attached to. When a 30-gram object is attached, the spring stretches 9 centimeters, which equation relates the mass of the object and the length of the spring. So I usually start by teaching y equals kx, but in this example, because the length is varying directly with the mass, the length is going to be s, and mass is going to be m. And k here represents our constant of proportionality. We always want y over x to calculate. I'm just trying to help you see which way are you going to divide these two numbers, because it looks to me like you just did it backwards. So if this was y over x, we're going to do s over m. So we're going to do the length of the spring, which is 9 centimeters, over the mass. Divide both of these numbers by 3, and we get 3/10. So s equals 3/10 m. This is your constant of proportionality that goes right in there for the letter K. Caleb made a table below to show the number of hours he works and the amounts he earns over a 4-week period, which describes whether the relationship between the earnings and the number of hours represents a direct variation. So if it's a direct variation, the proportions will be the same. So if you take like 140 and divide it by 12, then you take 170 and divide it by 15, 200 over 18, 230 over 21, it's not going to be the same. This is, I'm just going to show you what they are when I divide. Again, I'm doing the bottom number divided by the top number, and that's how I get 11.6 repeating. 170 divided by 15 is 11.3 repeating. 200 divided by 18, and at this point you really can stop. You don't have to keep checking because you already know that they're not the same. So let's see, the one that's correct says the ratio of earnings to hours are not the same each week. Yes, so the earnings do not vary directly with the hours. Again, because these numbers are all different, this is not a proportional, or it does not have direct variation. It doesn't represent direct variation. Question 8, given that y varies directly with x in the table, what is the value of y if the value of x is 7? So what we can find out here is that, let's see, 12 over 2 is 6. Yeah, so you're trying to find the multiplier. What do you multiply the bottom row, the top row by to get the bottom row? And so we're multiplying everything by 6. 2 times 6 is 12. 4 times 6 is 24. 6 times 36 is 6. 10 times 6 is 60. And so that's that varying directly. So if x is 7, if we had a 7 in here, 7 times 6 is 42. Which representation has a constant variation of negative 2.5? Well, I can see that right away. And it's not letter C because this is not a proportional relationship because of that plus 1 back there, so you have to be kind of careful on that one. So I'm thinking we might have to check all of these. That's 2.5. That's a half and that's 1. That's a half and that's 1. Oh, negative over negative. Okay, A is out because when I take a negative and divide it by a negative, I'm going to get a positive. So this one would give you positive 2.5. Negative divided by positives. Check all these in a calculator, but 10 divided by 4, 15 divided by 6, and so on. That's all negative 2.5. Letter C is not a proportional relationship because of that plus 1. So there's not going to be a constant of variation. And the same thing with letter D. These graphs that are proportional or have these constants of variation, they have to go through the origin. And this one does not do that either. Okay, I hope that was helpful. Let me know if you have any questions or if you need me to look at your next quiz attempt.